First thing when you do a picture, you gotta do, of course, draw the picture. I have technology. Oop, not fluing. Flying squirrel. There's a good one. Copy. Paste. There we go. There's my flying squirrel, but now he's really, really big, so I gotta make him small. Okay. What do I know? I know I'm going to be doing something with triangles. That's the name of this chapter. There's my squirrel. How high is he in the air? 12 feet in the air. So there's a lot of assumptions that sometimes you make in these word problems. And yes, I mean, you can put your hand up and you can ask me. But if there's a question with a tower, we assume they're perpendicular. If it's got a tree, same thing. Most trees grow perpendicular to the ground. We assume there's a 90-degree angle there. So when it says there's 12 feet in the air, that means to the ground, he's a distance of 12 feet. I don't care what direction he came from. I don't care what direction he's going. Gravity assumes he's going to fall to the ground, but that's 12 feet in the air. Okay? Now, next thing, angle of depression of 48 degrees behind him. Well, it doesn't really matter what's in front, what's behind, because you might draw him facing that way, you might draw him facing this way. But what's angle of depression? You guys remember? Good, some of you do. It's always from a horizontal. Angle of depression is from the horizontal down, okay? That's the angle of depression. What's angle of elevation? Because you also have that in your problems. From the horizontal up is angle of elevation. Interestingly enough, these are exactly the same angle, okay? If there's a plane here, and this is me on the ground, if I look at the plane, that's my angle of elevation to the plane. That's also, if the plane's looking at me, that's its angle of depression. It's exactly the same angle. Okay? There's a relationship here. If these are two parallel lines, and we assume they are, this is called a special term. It's called a transversal. And this angle will always equal that angle. So that may be helpful in some problems. Okay? So, see a nut? Here's my nut. Sorry. That's his nut. So from the horizontal down is 48 degrees. Where do I draw that? Do I draw it here? Or do I draw it there? First one or the second one? Yes, don't put it in there. It's not in there. It's from the horizontal down. That's 48 degrees. Okay? Now on the other side, he also sees one at an angle of 32. So if I want to draw it kind of accurately, that's from the horizontal down. It's a more shallow angle. It's not quite as steep, so looks reasonable. Okay, what's the question? Here's his other nut. Question is, how far apart are his nuts? Okay, that's X. That's this whole thing. Now, are you going to assume this piece is the same as this piece? Don't, because they're not. Okay? So what do I do? What can I do? Lucas? Okay? Because there's more than one option here. This is actually, like the first question on your sheet, There's a right angle here. I could use just grade 10 methods. So I'm going to do it with a grade 11 method. Zach?
Subtract 90, subtract 48 from 90, and
Okay, so you're seeing, hey, I can get this angle and I can get this angle. I'm going to need an angle inside this triangle, right? Like this thing doesn't help me, right? It's outside of my triangles. But let's think about this a different way. How far is it from there to there? That's 180. Okay, so if this is 48 and that's 32, do you guys know how to figure that out? 48 and 32 is 80, so all of this must be, okay, so that's what I'm going to do, okay? All of this is 100 degrees. And if I think sine law, I know sine of 100 over x is equal to what over what? Either that, okay, well either this is the angle opposite that side, right? I could have that relationship, or this angle and that side, okay? Now, what's this yellow angle? $32. Yeah, right? Because this is parallel with that, remember what I was just saying? This is the same angle as this. This angle of depression is the same as that angle of elevation. And vice versa, this is also 48 degrees down here. Okay? So now I can go sine of 100 over x is equal to, which one do you want to pick? Doesn't matter, let's use 48. Sine of 48 over, but now I don't know this, do I? But how can I get that? Let's call this y. Okay, I got two unknowns, I need to find something. X is what I'm trying to find. So first I need to get y, but what do we got here? Right angle triangle. And to get y, I know sine of 32 is opposite over hypotenuse, okay? Right? 12 is the opposite. Y is what I'm trying to find. If I got y, I can solve for x. So what's the shortcut? Y is 12 over sine 32. And if I do that, I get 22.65. Don't round that too much. Now I'm going to put that in there. Solve that thing for x. Okay, that times that divided by that. Am I in degrees? Yes, I am. Sine of 100 times 22.65 divided by sine 48 is 30.01. Rounded to whatever it asked you to round for. It didn't say, so let's call it 30. Nice round number, okay? Do I have units? 30 what? Feet. It's an American question. It's the American squirrel. So, is that the only way to do it? No. I also could have solved for that piece using SOHCAHTOA. I can use a tangent ratio, right? Because I know that angle, I know the opposite, I can solve that. Let's call it like x1. And then vice versa, I could use a tangent ratio there and solve that for x2. Add them together, I'll get that. But again, because this is grade 11, I thought I'd use some sine law. Okay?